So the other really important thing about my talks is to not listen to the content so much, but to pay attention to the background photos. So this is where I really devote the largest chunk of time in preparing a presentation. And I liked this one because I do think it's really cool. I don't know, the first rule whenever you move, right, is to set up the stereo. That's the first thing you set up, and I just think it's really awesome. You just plug the white into white and the red into red, and everything works. And so I think choosing the name components for what we're going to talk about today is a great idea. I mean, I don't know. I've been coding, almost for 30 years now, and I'm getting really tired of building the same things over and over and over again. So I've been doing front-end stuff for maybe 10 years. And I think this idea of like reusable components is really powerful. Like there's a lot of common functionality on the web today, and everyone is pretty much writing it from scratch. So let's just look at a couple news sites. How about like drop-down menus, right? Wouldn't it be nice if there was like a custom element for this? We can look here on Huffington Post, CNET. They all, like every one you go to, they have drop-down menus. How about photo carousels? How many people here have built a photo carousel, right? And what are you going to cache? Are you going to cache all of them? Or are you going to download them all at once? Are you going to lazy load? Are you just going to cache the ones that are right before and on the left and right? And so all of these, I looked at retail. So Zappos, I looked at clothing, I think. Zappos and 6pm.com, and my favorite, Brooks Brothers, all have photo carousels on the front page, right? And they all built them from scratch, right? That's a reusable piece of code that could be easily extended with CSS and HTML attributes if it was an existing web component. And then, there's also all the widgets that we're all familiar with. And we can embed those in our websites pretty easily. We've gotten pretty good at it. But the developer of the widgets have to do heavy lifting, and the embedding of that snippet sometimes can be more complex, and having a way to make that more reusable and to develop more familiarity with it would be great. So as if all of that wasn't motivation enough for web components, there's this chart from the HTTP archive. Actually, Ilya Grigorik downloads the data from the HTTP archive and uploads it to BigQuery, and then he started this website called BigQuery.es. And you can read this article. He figured out a pretty accurate query to find third-party content as opposed to the first-party or main website's content. And so, like at the median, I think it's something like 50 requests are first-party and 40 requests are third-party. 40 requests are coming from someone other than the person who built the website, who owns the website. And as we get higher and higher in the distribution, it actually crosses, and third-party content is more than 50% of the resources on the page. So the use of third-party content of these components is big. And so if there was a way to make them easier to use, more reusable, and more robust, that would be great. And so that brings us to web components. Now, before we get started, I want to do a slight digression. Web components are very promising, but I'm going to talk about the ugly performance underbelly of web components. I should have gotten a great background photo for that. But this is the one I have. I'm going to talk about SPOF, single point of failure, right? So it's like the weakest link in the chain, right? Traditionally, people with computer backgrounds think of single points of failure in terms of hardware and hardware architectures. And so here's the canonical figure for SPA from Wikipedia. And what we see is that there's only one router. So if the router goes down, there's no redundancy. It's a single point of failure. And this architecture will be belly up, right? They don't point out that the application server is also a single point of failure. So we're familiar with this when it comes to hardware. And we've all learned the lesson. I mean, I remember 14 years ago, like building big websites and having to learn this lesson and get multiple VIPs and multiple database servers and having redundancy. And I think most of us have gotten beyond that now. But what I don't think many people are familiar with is what I call front-end SPOF. And this is where you can have something in the front-end part of your code that will bring the website down. And this seems far-fetched, and maybe I am exaggerating it a little bit, but not too much. Again, like the background photos, like you know what I'm going to talk about on this slide, right? Blocking, right? We all know, right? We're here at the meetup. We know that scripts, style sheets, and fonts can block the page from loading, can block the HTML parser, can block rendering, right? So I want to look at that. I want to poke at that with in the browser a little bit. If you're not familiar with these tools, I want to highlight them. So the first one is Gazillion, and then we'll look at web page test. Okay, so I'm going to try this. And cool, there we are. That's a browser. And I mean, in addition to changing the slideshow keyboard shortcut, I never had any success switching in and out of PowerPoint. And I tested it today and it worked. How many people here have used Gazillion? So this is a tool I created when I was writing my second book, because in my first book, I wrote a test page for every test case, performance test case in the book. And in the second book, when I was talking about how scripts get loaded, come on in. There's some seats and there's pizza in the back. Come on in. And I figured out all the different scenarios I wanted to test, the matrix of the different techniques and the different scenarios, and it was going to be something like 500 unit tests I was going to have to create. So I just created a tool to do it. And so it's really easy to use. Like I just mentioned that script, style sheets, and fonts block rendering in the page. So let's create a test case to prove that. I'm going to have a script. By default, it's going to have a 2-second delay. Well, here, no, let's remove that first. Let's do an image. I'm not going to have any delay on the image, right? I'm going to make that 0. All right? And now I can create this test page. And there's the image. It's this little fish. I like the ocean, so all the test images are sea critters. And it showed up right away. It showed up immediately, right? Well, now what happens if we add an external script that takes 2 seconds? It blocks the page. It blocks the HTML parser for 2 seconds, which means none of those DOM elements are created, which means nothing is rendered. And it's not just scripts. We can put a style sheet in here, and it's going to do the same thing, however long it takes. So most assets are going to download worldwide average 300, 400, 500 milliseconds. But every once in a while, there's an issue, and a resource can take a long time to download. It could take 5 seconds. So then the entire page is white for 5 seconds. That's an outage. A lot of users aren't going to wait 5 seconds. Even worse is if the server, web server, is so overloaded, it's going to time out. So depending on the browser, a timeout is going to leave the browser blank white, for 20 to 120 seconds. And that's definitely going to be an outage for users. In fact, if you look, I never used to be able to tell this story. I could tell it now. Google Analytics had an outage. I think it was May 15th, 2011. and it timed out. It only did it for a portion of Europe, I think. And all these websites, a lot of websites have Google Analytics, right? All those websites had a blank white page, and it was considered a major outage. And then just more recently, when I gave this SPOF talk at Fluent 2 or 3 years ago, the day before I gave the talk, Facebook had an outage. And all the people who were including the Facebook widget in a synchronous way had a blank white page. So this happens to even the big guys, right? And probably happens even more to smaller sites that don't have the dedicated resources that these big guys do. So Gazillion is a nice tool that lets you create different scenarios. Well, what if I put the style sheet, what if I put this down in the body? What if I put it below the image? I don't know. Let's see. That still blocks, right? You can play around, and this is how I find a lot of the interesting techniques or hacks about how to make things work faster. The other thing I wanted to show is web page test. So web page test, how many people here use web page test? Yeah, that's good. So I don't know if you know about it, but there's this feature called SPOF. So I wanted to test, I think it was CNN.com, and I noticed in there that they have this Optimizely script, right? So here, let me bring that up really quick. I have to set the microphone down. Okay, there it is. There it is. Okay, so I happen to notice that they are loading a lot of scripts synchronously, which means that the script is going to block the page, right? Now, they're loading the ones from their CDN synchronously. And to me, like, it's not guaranteed, but if the CDN is failing, your website is probably failing as well. So, like, you should try to load all your scripts asynchronously, but the ones on your own site, I can understand if maybe you're not as proactive about those. But think about all the ones from third parties where you might not even have SLAs, you don't really know how good or bad of a job they're doing keeping their sites up. And so I'm not saying anything about Optimizely. I don't know if they've ever had any outages, but I just noticed it's one of the first third-party scripts that I find here, and it's being loaded synchronously. So we can do this test in web page test, where we go to CNN.com. Oh, I thought you were leaving. That was okay. So we can do this, and we can just start the test. So what I did was under this SPOF, and you can read it, it's basically going to black hole the requests. Any requests that go to cdn.optimizely.com are never going to return. And so we can see what happens. So we can start this, but I've already run it. And it's really kind of interesting. What we see here, let me go to 5 second. So we have without SPOF up at the top, and with SPOF at the bottom. And so I mentioned, depending on the browser, it could be 20 to 120 seconds. I tested this in Chrome, and after 20 seconds, Chrome will give up on a response if it doesn't receive anything. So what we see is when I black hole, when I never get a response for this script that's loaded synchronously, the bad way, it makes the page white for 20 seconds. Now, I don't know about you, but if I was CNN.com, I would not want to bet the rendering of my website on a third-party script, right? So how do you get around that? Okay, now let's go back to, so remember those tools, Gazillion and, come on in, Gazillion and web page test, especially the SPOF tab, are a good way to test those things. Now let's see if we go back. I swear I never did that before. That's awesome. So, and there we see the results. So, what's the fix, right? This is synchronous. Come on. Yes, thank you. Thank you. This is synchronous and it's beautiful. It's very well organized and it happens in a repeatable way. It happens in a certain order. But the downside is if one part of that synchronous flow gets slowed up for some reason, the whole thing is going to get slowed up, right? So, you could do async, and it can be a little messy, right? It can be a little chaotic. Stuff is happening independently. You've got callbacks, you've got race conditions, and you've got a code for that. But if you do it correctly, everything is going to get done more quickly than if you did it synchronously. So this is what we want to do with these resources that block. We want to figure out how to make them not be synchronous and block the page. We're going to do them asynchronously. So here's the technique that we're all familiar with, I'm sure, for loading scripts asynchronously. Instead of saying using HTML markup, we're going to do it with JavaScript. We're going to say find the first script in the page, because I need an insertion point. Create a new script. I'm going to skip over this, but this is a nice thing to do. It's friendly to other scripts in the page. I'm going to set async to true, and then I just set the source, right? So this could be Optimizely, cdn.optimizely.com, and then I insert it into the DOM. And if you load scripts this way, they will not block the page from rendering, okay? And variability across browsers is a huge problem, but this technique works in every browser, right? And so we'll actually here, let's step back out because we were so successful last time. Let's step back out and go to Gazillion. And in Gazillion, I had a different name for this. I called it script DOM element. There's no official name for this technique, but that's what it means, script DOM element. And if we load it that way, and if you look at the source code, when I generate the page, everything's going to render. There's no blocking. And then we see below, it actually did take 2 seconds for that script to load, but because we use this technique, it does not block the page, right? And you could look at the source code here to verify that that's the code template that's being used. So this is a very powerful thing. Okay, let's get back on the highway. Web components. We came here to talk about web components. We had a slight tangent to talk about SPOF, but that's the ugly underbelly of where we're headed with web components. But let's go ahead and get started. So I think this is a great, I just picked this as the representative of web components. It's a great talk by Eric Beidelman from Google. If you haven't listened to it, he also has written some really good articles on HTML5 Rocks. I think that's where they are. But if you like to watch video, this is a great video. It'll give you an overview of how web components work. And he'll talk about the 4 main pillars of web components: HTML templates, shadow DOM, HTML imports, and custom elements. Now, for the sake of time, I'm only going to talk about HTML imports and custom elements tonight, right? I'll just give you a quick mention about the others. HTML templates, templates are nice. It's a way to get a template down to the browser. It's parsed, but it's not rendered. And then you can instantiate it in the browser, and you can read his article or watch the video and figure out how to do that. Shadow DOM is a little more subtle and I think a little more complex. It lets you have encapsulation of your code and of your CSS styling within the code, and so there are benefits to that, and it gives you a little more access to the underpinnings of elements in the page. But I'm mostly today going to talk about HTML imports and custom elements. Now, when we talk about these custom elements, we need an example that we're going to use. So here's my example. This is what I call the nav timing custom web component. And it's a button, and if you click on the button, it will show all of the W3C nav timing spec times from the current page, right? And it will do it in order, and it looks very nice. And so you can get this nav timing info. Now, before we go too much farther, let's talk about support for web components. Again, like, I'm not getting the feedback that I wanted from these. I thought this was a good one. Okay, you go search. You're going to talk about cross-browser support. What are you going to search for in Flickr? Try to think about these things. Like, it's hard to do. It's only in Chrome. These are only, some pieces are supported in Firefox, and I haven't tested Opera. If, Opera is built on top of Blink, so, they might be supported there. I didn't test, but I did, I think by and large, like if you want the whole kit and caboodle, Chrome's the only one that's going to get it. You can get it in the stable version of Chrome by turning on these flags under Chrome flags. But if you're on Canary, I don't know about 35. I'm on 36 now. I didn't test 35. 36 plus, you don't need any flags, right? You can use these examples I'm going to talk about today, and they'll work just fine. And I will also mention that there's this project called Polymer, which is a polyfill for a lot of what we're going to talk about today, and there's a URL. You can go check it out. But I haven't tested it either. Okay, so we're going to talk about HTML imports and custom elements. Let's talk about HTML imports first. How do they work? It's a link, and it's a new rel type called import, and you give it an href. Okay, so what happens with this? The browser will go and fetch this, and then it's going to do something with it. So in this case, navtiming.php is going to contain actual HTML. It's going to contain this HTML, and it actually has an open HTML tag and an open body tag, but I left those out just to have room so you can read it. But here's the guts of the nav timing web component. It's just a container that has a button in it, and when you click the button, it calls this function do nav timing, and then there's actual script in the import navtiming.php that implements that function. It pulls up the nav timing out of window.performance.timings. Now, this div ID is important. Let's remember that. Nav timing -content. Okay. So you've downloaded this HTML import into your page. How do you use it in your page? How do you insert that imported HTML into your page? Okay, you're going to get your hands on the link, right? The link rel import that just got downloaded, and you're going to grab the content out of it. And that's why I said remember that ID. So you're going to grab the content out of it. You're going to find that container, and then you're going to clone it and insert it into your page wherever you want. Does that make sense? Any questions about that? Good, because I don't know this that well. Okay, so here's what your page would look like. You're pulling in this HTML import in the head. You've got a target div where you're going to insert the import, and then you're doing that stuff that I just showed you. Get my hands on the link, find the container, clone it, and insert it into the target. Now, does anyone think that there might be a race condition here? And if so, can you see it? Where if you're not careful, you're going to want something that's not ready yet. Yeah. Where?
There's two things going on. Because, like, let's say rel import application primary actually has imports, and it's importing another import, and that import is importing this one, then you have an issue. But then also, if you haven't imported it yet and you're hitting your JavaScript, you're not going to find that.
Exactly. So this is Estelle, the awesome velocity speaker and other well-known tech speaker. And what she said was, first you could have the import, and it could be importing other stuff, and you could even have a cyclic import cycle. But the main one that I'm thinking about is this one, where that Estelle mentioned, where I'm downloading this thing, and normally it's going to come back in 200 or 300 milliseconds, but what if it takes 2 seconds? What if it takes 10 seconds? If the browser just charges ahead and executes this code, it's not going to be able to find the content container because the import's not back yet. It will be able to find the link DOM element, but not the content that's inside it because it hasn't returned yet. And so you're going to get a JavaScript error. All right? So what's this mean? How could browsers defend against this? You know what I'm going to say? Blocking. Browsers thought, well, okay, or at least Chrome thought, okay, well, we'll fix this by blocking, right? So now, in addition to scripts, style sheets, and fonts, HTML imports are going to block rendering in the page. So it's interesting. Now, I will say all of this stuff is new. I forgot to add that in the slides. All this stuff is new, which means that it's changing underneath us. So I had to like completely rewrite my examples from when I blogged about this 6 months ago. But it also means we have an opportunity to influence the future. So that's something I hope will come out of this, is you'll think some of the things we were talking about at the end make sense, and maybe lobby with your with the spec writers to change how it's implemented. So in Chrome 3334, if you have a link rel import, the parser stops when it hits the very first script tag. Because the thought is, or thought was, that you could be importing something and then you're going to have a script tag that is going to try to reference that import. So I can just charge ahead, do the link, and charge ahead and create DOM elements. But when I get to a script tag, I have to stop. The browser has to stop because it might have a reference back to that import and I don't want to get an undefined symbol error, right? So that's what it used to do. Now what it does, I think, is cleaner, but more oppressive, is more disruptive, is it will treat it just like, pretty much just like a link rel style sheet. We saw in Gazillion just a minute ago when we did a style sheet, the whole page would block, and that's what happens now, right? The whole page blocks. But it's really interesting. It will give up after 5 seconds. The browser, Chrome Canary, will wait 5 seconds for it to get back, and then it will charge ahead until it reaches a script tag. So if you just happen to have a link rel import kind of at the bottom of your head, and then you had a bunch of HTML without any script tags, all of that stuff would get rendered. But then when you hit the first script tag, everything below that would be blocked. Okay, so let's try to look at some of those. So here are my examples. I had a designer help me with the UI. And there we go, thank you. And so here's just the default way I described it to you. So this is Chrome 3334. I had to turn the flags on, and remember what happens here is it will charge ahead with a link rel import until it encounters the first script tag, and the first script tag is right below this paragraph, and so it stops there. And in this case that makes sense because that script tag is where I'm pulling in the contents of the link rel import so I avoid any errors. If I try it in Chrome Canary, okay, boom, 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 there we go. It blocks the whole page, right? Just like a style sheet. Now in this case, I only have a delay for 5 seconds, but I ran this in web page test, and I black holed this is really hard for you to see. I black holed the HTML import, and it's really interesting what happened here. I mean, I thought it was just going to block, up until about 4 hours ago, I thought it was just going to block the entire page for 20 seconds, just like a style sheet. But they did some interesting behavior here. So what we see is, where's the times? There are the times. Okay, let's go to 5 second chunks. 5 second chunks. Thank you very much. Okay, let's go back up here. So this HTML import takes 5 seconds to come back. So even in the unblack-holed, version, the original version up top, we have nothing at 5 seconds, but at 6 seconds, the page renders. And we have the nav timing button, the custom element web component there. But in this one, after 5 seconds, so in this one, it's black hold. And I would think the link rel import would block all rendering for 20 seconds, just like a style sheet, but it doesn't. After 5 seconds, Chrome gives up on it and charges ahead, but then it stops right after the first paragraph because it encounters a script tag. And that is going to block it until it finally gives up at 20 seconds, and then we never got the import, so it renders the rest of the page. So it's a little nuanced loading, but the short of it is, if a link rel import is slow to return, it's going to be a bad user experience, right? So here we are back at blocking. So that's not good. Okay, so that's HTML imports. Really quick, let's talk about custom elements. Good timing. How do custom elements work? Well, we're going to start with an HTML import. Now, you actually don't have to use HTML imports to take advantage of these other technologies, Shadow DOM and HTML templates and custom elements. But to me, the key thing we started with that I think is the most powerful is that these are reusable web components. And the way that they're reusable is they're shared. And that means they're going to be coming in as separate requests. You're not going to be embedding them in your page if they're these reusable web components. So I think HTML imports is going to be a critical piece of any popular web component. So we're going to start with a link rel import. This time it's nav timing CE for custom elements, so it's slightly different. And what's going to be in there? The only thing that's going to be in the HTML import this time is JavaScript. So I guess it's a misnomer. I'm going to create a prototype that I'm going to call the nav timing prototype, and I'm going to add to that a callback whenever one of these custom elements is created. And that callback is just going to set the inner HTML to have that input button that says nav timing on it. And when you click on that button, it's going to call the do nav timing function. And then I have to register that element, right? And then I can define the rest of the JavaScript to do nav timing. Now, this is important. The name of the element that you're going to register has to have a hyphen in it. That might be too low. People might not be able to see that. Why? Because no HTML tag, no valid HTML tag, built-in HTML tag, has a hyphen. And so this is a way that browsers can distinguish custom elements from built-in elements. And we'll see how that's important in a second. So now I have this imported custom element. How do I actually insert it into my page? I registered that tag, nav-timing, so I can say open nav-timing, close nav-timing, and that's it. Pretty clean, right? That's really powerful. Now, here's what my HTML page looks like that's using this reusable web component, custom element. It's pretty sweet, right? Is there a race condition? Yes, there is. Suppose this takes 10 seconds and the browser charges ahead and gets here. What's it going to do? That's what happens. Estelle was right again. It's just going to ignore it. So, in addition, but the link rel import, the browser doesn't really know if it's going to be an HTML template, if it's going to have HTML in it, like the first example of nav timing, or if it's going to be all JavaScript with a custom element like this one. So it treats them all the same because it doesn't know what the response is going to be. So it's still going to block the way that we talked about for base HTML imports. But in addition, if it does move forward, it's going to ignore any hyphenated tags. And that's why it's important that they have a hyphen in it, so it knows that it can ignore it and not generate some broken HTML. So, just like with scripts, we can find a way to work around this blocking behavior. And that's by loading HTML imports async. You know what I'm going to say. Here, say it with me. var link equals, okay, here, I'll say it. Just like we used to create element script, we're going to create element link, right? We're going to set the rel type to import. We're going to set an onload handler that does all that stuff that I talked about before, where we, in this case, I'm doing the first version of the nav timing custom element, nav timing web component. It's going to find the link, get the container, and clone it and insert it into the page. When the import actually is done loading, that's how we avoid a race condition. We have a callback. And then I'm going to set the href, and I'm going to append it to head, right? So if you do this, you can get around the blocking behavior of HTML imports. There are some other things that I blogged about if it contains document.write, but let's just assume that away. So web components are very powerful. There is a way to get around the worst performance problems, but we can think of this as a technique. It's really a hack, right? We shouldn't have to do this, especially for something that we're just in the middle of speccing right now. We shouldn't have to. I mean, we have all this insight that we gained over the last 10 years about how we need to be able to control the loading of resources like scripts and style sheets and even images. We want to be able to lazy load them. We want to be able to get a callback when they load. We want to be able to have them block content if we don't want to have a flash of unstyled content. But we want to be able to load them async if they're not going to affect the current page, or if we're okay with the page jumping. So here are some suggested fixes that I've made to the discussion. There's a proposal called resource priorities that talks about this lazy load attribute, but I think for link rel imports, just like style sheets and other assets, we need a lazy load attribute. So this is a way of saying load it, but don't do anything with it. Don't block for it. In the case of custom elements, it's kind of great that it charges ahead and skips over. But then if that custom element is something critical to the page, the user's going to see the page with this custom element missing. And they might think the page is broken, or the custom element might be huge and really cause a jarring flash of unstyled content, flash of unavailable content in the page. So I might actually want to enforce synchronous behavior, and there's no way to do that now with markup. So one idea that I had was that there should be an elements attribute. And you don't have to, but if you want to, you can specify the custom element tags, and when the browser encounters, associated with this import, and when the browser encounters that custom tag, if that import isn't done, then it blocks, right? In some cases you want blocking, in some cases you don't. I want my cake, and I want to eat it too. And finally, it's kind of unfortunate that we piggybacked on the link tag, because according to the spec, you can only put link tags in the head. They work when they're in the body, but it's invalid HTML. Some people care about that. If you don't care about that, you can actually work around a lot of these problems. You could move the link lower in the page, and if nothing else, it'll be closer to where the element's going to actually occur, so the page will make more sense to someone trying to figure out how it's coded up. But you can get around some of these other behavior problems. I think we should just change this part of the spec and say that it's okay to put links in body. Okay, wrapping up. Web components are awesome. I think a key to any really successful web component, most successful web components, is going to be HTML imports. And HTML imports, the way they're moving now, block rendering in the page. So that's troublesome. Hacks exist to work around it, but really there are a couple ideas out there for how we can change the spec so that we can do it without using these hacks. We can do it in markup or with functionality built into the API. And finally, whether you're using HTML imports or not, you're probably using scripts and style sheets. So use webpagetest.org and use that SPOF tab and put all of your third-party scripts and style sheet domains in that list and see if your page gets blocked from rendering. And if it does, go and find out which one is causing that blocking and figure out how to load it so you won't get front-end SPOF on your website. That's it. Thank you. Okay, any questions? Yes?
So mobile devices are traditionally been sensitive to workarounds, JavaScript, limited processor speed, and whatnot. Given that, do you think the workaround that you presented today is worth doing for mobile websites, or should we wait until the specs have been finalized first?
Well, I think it's kind of early to. For people live streaming, the question was, will these workarounds, basically the async loading, will it work on, do I think it'll work on mobile devices? So I'm not sure if there's any mobile browser right now that supports link rel imports, but I know of a website that dynamically created link rel prefetches. I think they did it either in the old Android browser or in Chrome on Android, and it worked. So I'm pretty confident that the link rel import async hack would work as well, and as well as the other hacks around loading style sheets and prefetching and pre-rendering with JavaScript. Yes?
It's 2014, and we've all sort of spent many years dealing with the fallout of the way script loading and other static assets loading works in pages. What's your sense of the I guess atmosphere around spec implementers' opinion of optimizing these types of things?
These types of things being loading scripts or just in loading assets. So the question was, we've been loading assets, since the beginning of the web, and for the last 10 years, more and more JavaScript and CSS, and we've also gained more awareness about the performance problems around those. What do I think about the awareness in the spec community around trying to address some of these? And my old office mate at Google, Ilya, I mentioned him once or twice in this talk already, Ilya Grigoric. He's the one who I think pushed this proposal for resource priorities. And so I recommend people check that out. And it talks about adding these attributes, and I can't remember them off the top of my head, but adding them to basically every tag that generates an HTTP request to do things like lazy load, to not execute JavaScript. You might want to download a 500K bundle of JavaScript, but you don't need it right now, so you don't want your underpowered device to be parsing 500K of JavaScript. So I think hopefully resource priorities will get adopted. Any other questions? Okay, I think, I'll be here if you want to come up and talk later, that'd be great. And I think Aaron has some raffle giveaways to do. All right, thank you very much.